All right, let's dive right in. Today, we're cracking open a cosmic case file on a galaxy that seems to break all the rules. We're talking about a place with impossible angles, super intense star formation, and a decade-long explosion right at its very heart. This is the wild story of NGC 660.
So what you're looking at here is, well, it's beautiful for sure, but it's also just incredibly strange. You see the main disk of stars, right? The flat part. Now look closer at that other ring of gas and dust. It's slicing right through it at this totally impossible angle. This is no single quiet galaxy. Nope. This is the aftermath of a truly colossal cosmic collision, frozen in time.
And it's not exactly next door. This galaxy, NGC 660, is about 45 million light-years away from us, over in the constellation Pisces. I mean, to put that into perspective for you, the light that we're seeing right now, this whole galactic drama, it started its journey to us way back when mammals were just starting to take over here on Earth. Just think about that.
So this weird structure actually has a name. It's called a polar ring galaxy. And let me tell you, it's one of the rarest kinds of galaxies out there. So how does this happen? Well, imagine one galaxy, probably a spiral like our own, colliding with a smaller gas-rich galaxy. The bigger one just rips the smaller one apart, and all that debris, it gets captured and strung out into this incredible ring that orbits, get this, over the poles of the bigger galaxy. And that is the scene of our crime, so to speak.
All right, for the first part of our investigation, let's zoom in on the most obvious feature, right? That stunning, tilted ring. Because it's not just some quiet leftover band of debris. Oh no, it's a place of intense, fiery creation. So when astronomers pointed the Hubble Space Telescope at this thing and looked really close, they started to see individual points of light inside that ring. And as you can see in these incredible images, those little dots, they aren't single stars, not even close. They're entire clusters, these super dense stellar complexes where thousands, and I mean thousands, of new stars are being born all at once.
And just how new are we talking? Well, analysis shows that the youngest stars in this ring are only about 7 million years old. I mean, in cosmic terms, that is literally the blink of an eye. This is not some ancient fossil. It's a living, breathing, active stellar nursery, all kicked off by that violent galactic collision.
So what do all these clues from the ring tell us? Okay, first, we see massive, short-lived supergiant stars. That confirms these areas are super young. Second, there's a mix of ages, which tells us that starbirth isn't a one-and-done event. It's still happening. And finally, and this is a really fascinating detail, the stuff in the ring has a lower metallicity. That just means it has fewer heavy elements, which is a key clue to figuring out where all this captured gas actually came from in the first place.
Okay, let's shift our focus. We're moving from that outer ring right into the center. Because while the outskirts are just blazing with new stars, something very different, and honestly even more mysterious, is going on deep in the turbulent heart of the main galaxy.
See, a galaxy that's forming this many stars, a starburst galaxy, it needs a ton of fuel. We're talking about cold, dense gas that can collapse and create new stars. So naturally, astronomers pointed their radio telescopes at the core of NGC 660, fully expecting to find huge stockpiles of the stuff. But what they found? Well, let's just say they were in for a major shock. As this quote from the actual research paper says, the gas they found was, well, it was the exact opposite of what they needed. Instead of being cold and dense, it was incredibly hot and all spread out, tenuous. We're talking about 150 Kelvin. Now for us, that's minus 190 Fahrenheit, so yeah, freezing. But for gas trying to form stars, that's way, way too hot. And that created a huge puzzle. What in the universe could be heating all this gas up?
Okay, this next clue is, well, it's pretty wild. This is a position velocity map. I know, it looks complex, but what it's showing us is actually simple. It's mapping how fast the gas is moving right at the galaxy's core. And what it reveals is just astonishing. The gas is spinning together insanely fast, almost like a solid spinning record. This kind of rapid, unified rotation, it points to an immensely powerful engine at the very center, forcing everything to spin along with it.
And this is where our investigation really hits its climax. All these clues, the hot gas, the crazy fast rotation, they were all pointing to something extremely powerful lurking at the core. And then, in 2008, astronomers actually got to see it in action. The central engine woke up.
Totally by chance, mind you. During a routine radio survey, astronomers spotted this massive outburst. A brand new, intensely bright source of radio waves just appeared, right at the galaxy's nucleus. And this wasn't some quick flash. This was a sustained, decade-long eruption of just incredible energy.
This timeline really puts the sheer scale of this thing into perspective. So it was first detected back in 2008. It then got brighter and brighter for 4 years, hitting its peak in 2012. And after that, it slowly faded over the next 5 years. Again, this wasn't a quick pop. This was a long, sustained release of immense power.
So with all the evidence on the table, we've got the hot gas, the rapid rotation, and now this decade-long radio flare. It was finally time to nail down the culprit behind all this cosmic chaos in NGC 660.
And pretty quickly, 2 main theories emerged. Suspect A. Could this have been a really, really powerful supernova, a massive dying star that was just hidden deep inside the galaxy's dusty core? Or, Suspect B. Was it something way more exotic? Was it the galaxy's central supermassive black hole suddenly roaring to life?
Well, as astronomers gathered more and more data, the supernova theory started to fall apart. For one thing, the outburst was located precisely at the galactic nucleus. I mean, the exact spot you'd expect to find a supermassive black hole. Plus, when they got high-resolution images, they didn't see the expanding shell of an explosion. Instead, they saw a two-sided jet structure. This wasn't a bomb going off. It was an engine turning on.
The evidence was pretty much undeniable. The culprit was an active galactic nucleus, or AGN for short. And that's just the term we use for the insanely bright core of a galaxy when its central supermassive black hole is actively eating all the gas and dust around it. So what exactly went down here? You can think of it like a messy cosmic dinner. A huge cloud of gas, probably knocked loose by that galactic merger we talked about, started falling toward the central black hole. And as the black hole's gravity just devoured this material, not all of it went down quietly. A huge amount of energy was unleashed, blasting out these powerful two-sided jets of particles at nearly the speed of light. And that is what astronomers saw as that brilliant, long-lasting radio flare. And that, right there, is what makes NGC 660 so incredibly important to science. See, most active black holes we find have been switched on for millions of years. But here, astronomers caught one in the act of turning on. It's like a perfect natural laboratory, giving us this front-row seat to watch a supermassive black hole's feeding event right from the very beginning.
So the case of NGC 660 is pretty much solved. The impossible ring, a cosmic nursery for new stars. The turbulent core, home to a feasting supermassive black hole. But it leaves us with one truly mind-bending question to chew on. If that decade-long eruption we saw was just a snack for this black hole, what in the world happens when it sits down for its main course?